dawn does not bring peace. It marks the beginning of Africa's daily struggle for survival. Across the African savanna, the first light of day redraws the horizon. The sun provides more than warmth. It activates the entire flow of energy across the planet. Winds carry moisture from the Indian Ocean over the plains of the Serengeti. Each droplet in the atmosphere becomes rain, then evaporates again, closing the water cycle. Young grass grows in rhythm with the passing clouds. Insects, antelopes, buffalo, lions, and vultures all move according to the same current of water and light. Life on Earth is not scattered by chance. It forms an interconnected network through which energy passes from one level to the next. From photosynthetic plants to grazing animals to predators, no link exists in isolation. When the rainy season fades, the ground cracks, the grass withers, and herds begin their long journeys, traveling hundreds of miles in search of water. Every step and every breath are biological responses to environmental pressure. The Serengeti is more than a landscape. It is the place where the planet's heartbeat becomes visible, where energy, water, and life merge into a continuous cycle. A journey connects rivers, grasslands, and rainforests, all pulsing to the same rhythm, the heartbeat of life. The rainy season has ended. Across the Serengeti plains, dry winds move over fields of yellowing grass. Each year, life here follows a harsh rhythm of rain, growth, migration, and renewal. When the water recedes, the entire savanna begins to move. Millions of animals start the greatest migration on Earth. On the horizon, the first herds of wildebeest appear. Each adult weighs around 550 pounds and moves in continuous waves. They have no leader. Instinct and the scent of damp grass after rain guide their movement. Zebras and Thompson's gazelles follow close behind. All three species share the same space, but feed on different layers of grass. Zebras consume the tall, coarse grass, clearing the way for wildebeest. Wildebeest graze on the medium layer, while gazelles take the tender shoots left at the bottom. This difference in feeding strategy prevents direct competition. It is a form of coexistence among herbivores, an example of natural selection, maintaining energy stability. In the sky, clouds of dust signal the approach of migrating herds. Vultures and fish eagles patrol above, tracking every movement. On the ground, Predators are already in position. Lions, hyenas, leopards, and wild dogs each wait for the right moment. For them, the migration is not only a feeding opportunity, but also a test of survival. As the herds cross the lowlands, danger hides beneath the grass. Nile crocodiles lie motionless in the mud, bodies longer than 13 feet. They can fast for months, waiting for the flood of migration. A single roar breaks the silence, and the surface of the river explodes. A crocodile strikes its first prey and spins in a violent death roll. Within seconds, the hunt is over. The rest continue crossing because hesitation means drowning or being trampled. The energy structure of this ecosystem functions as a single living system. Grass captures energy from sunlight. Herbivores convert that energy into biomass. Predators regulate population density, preventing the system from exceeding its carrying capacity. Finally, microorganisms and scavenging birds complete the cycle by decomposing matter back into the soil. On a biological scale, this is an open energy ecosystem where matter is recycled, but energy flows in only one direction, from the sun to every living organism. Each link in this chain has limits. When one group declines, the others adjust to maintain balance. This is why, after tens of thousands of years, the Serengeti still supports one of the densest concentrations of life on the planet. The energy structure of this ecosystem functions as a single living system. Grass captures energy from sunlight. Herbivores convert that energy into biomass. Predators regulate population density, preventing the system from exceeding its carrying capacity. Finally, microorganisms and scavenging birds complete the cycle by decomposing matter back into the soil. On a biological scale, this is an open energy ecosystem where matter is recycled, but energy flows in only one direction, from the sun to every living organism. Each link in this chain has limits. When one group declines, the others adjust to maintain balance. This is why, after tens of thousands of years, the Serengeti still supports one of the densest concentrations of life on the planet. This system is never static. It is a network constantly reacting to climatic variation. Rainfall, wind, temperature, and sunlight determine the biological rhythm of millions of individuals. During the dry season, ground temperatures can exceed 104 degrees Fahrenheit. Dust and wind create harsh conditions, but they also trigger movement. Herds sense humidity changes through smell and plant signals. They leave the dry central plains and move north toward forming storms. Migration is not only a search for water, it is a large-scale redistribution of nutrients. The waste of millions of animals enriches soil along the route. Organic matter and seeds spread from one region to another, maintaining the continuity of vegetation across the plains. The Serengeti is therefore more than a spectacular landscape. It is a vast self-regulating mechanism. No single animal understands the system, yet all contribute to its stability. In the sky, flocks of migratory birds move with the prevailing winds. They mirror the same cycles as the herds below a biological clock that spans the entire region. At night, the ground cools rapidly. Predators take turns hunting. Roars, footsteps, and the wind blend into one continuous soundscape of life. By morning, mist settles on the grass. The sun rises again, and light filters through the dust left from the night before. The first beams reveal new footprints pressed into damp soil. On this savanna, every moment serves a larger cycle. This is why the Serengeti stands as the clearest symbol of natural biological balance. It does not require human intervention to persist. Balance is achieved through interactions among energy, water, and adaptation. During the wet season, temperatures drop, humidity rises, and grass reaches its peak growth. Herbivores give birth, providing abundant prey for carnivores. When the dry season returns, grass becomes scarce and many young do not survive. Natural selection continues silently but efficiently. This ancient process has operated far longer than any civilization. The Serengeti, therefore, is not only a region of Africa, it is a global symbol of regeneration and the natural regulation of energy. In the energy chain of the Serengeti, lions stand at the top. They dominate not through brute force alone, but through a balance of strength, strategy, and social order. A typical pride includes several males, multiple females, and their cubs. Females form the core, taking responsibility for hunting and raising offspring. Males defend the territory, drive away intruders, and pass on their genes to the next generation. This social structure is the result of hundreds of thousands of years of natural selection. In an environment where energy is always limited, cooperation becomes essential for survival. When moving, the pride acts with organization and purpose. They hunt at night, using lower temperatures and darkness as cover. Each individual knows its position within the formation. The lead lioness intercepts the prey's path, while others flank from both sides. The final strike usually comes from the most experienced female. The average success rate of a hunt is only about 25%. However, each successful kill can feed the pride for several days. An adult lion can consume up to 15% of its body weight in one meal. The remaining flesh is quickly taken by hyenas, vultures, and other scavengers. No energy is wasted. Across the plains, territory is defined by sound. A lion's roar can travel up to 5 miles under dry air conditions. It serves as both a warning and a declaration of boundaries. Young males are eventually forced to leave the pride, wandering for months before finding new territory. During this period, many do not survive. Fights between male coalitions are intense, ensuring the highest level of natural selection. Only the strongest individuals carrying dominant genes can survive and reproduce. In the outer regions of the Serengeti, lions share their prey base with spotted hyenas. These two species are direct competitors with the same targets. Lions hold an advantage in strength, while hyenas gain from numbers and endurance. Some confrontations last for hours over a single carcass. This competition does not harm the ecosystem. Instead, it maintains biological order. Every struggle is part of an ongoing redistribution of energy between species. Lions do not hunt continuously. They spend most of their time resting to conserve energy. In daytime, temperatures that can exceed 95 degrees Fahrenheit maintaining a stable body temperature is a physiological challenge. They regulate heat by resting in shade or lying near water sources for cooling. Their pale golden fur reflects sunlight. Their bodies are muscular, yet capable of enduring several days without food. They possess large hearts, powerful lungs, and jaws that deliver a bite force of about 650 psi, strong enough to bring down a buffalo or zebra with a single bite to the neck. Each individual plays a role within the greater ecological framework. They keep herbivore populations stable, they prevent overgrazing that could destroy vegetation. Their hunts create space for new grass to grow after herds move on. Through this process, the cycle of rain, migration, hunting, and renewal continues. During the wet season, lions follow the movement of prey herds. In the dry season, they gather near the remaining waterholes. Their distribution reflects flexible adaptation to climate variation. Lions are not isolated from their environment. They respond to every small change in water, vegetation, and sound. A lioness can detect the scent of an antelope from more than 3,000 feet away when the wind is right. Their hearing detects low-frequency movement at night, allowing them to locate prey by the sound of footsteps through grass. Beyond their ecological role, lions serve as indicators of ecosystem health. A decline in lion numbers often signals imbalance among prey populations or degradation of habitat quality. Researchers monitor lion population trends to assess the recovery potential of grassland ecosystems. From a scientific perspective, lions are not merely predators, they are regulators of energy flow. Every behavior, from roaring and territorial marking to coordinated hunting, contributes to maintaining equilibrium. As the light fades, the plains turn amber. Lions awaken from their daytime rest. The first sound is a deep, resonant roar that travels through the cool evening air. It is a confirmation of presence and a signal that the nocturnal hunt is about to begin. A soft wind carries the scent of damp soil. The pride disperses into the darkness. There are no loud movements, only the quiet motion of bodies preparing to hunt. In the distance, groups of antelope rest in tight clusters, relying on hearing and touch to detect danger. A lioness lowers her body and advances, step by step. 40 yards is the final limit before detection. When the moment arrives, the entire pride charges at once. The sounds of running, roaring, and wind merge, and then silence follows. The outcome may be success or failure. Yet with each hunt, energy is redistributed from grass to flesh, and from flesh back to soil. Lions hunt not out of brutality, but because the system's survival depends on it. It is a mechanism of life maintenance, not an act of dominance. When dawn returns, the plains fall silent. The nocturnal hunters retreat to their resting places, full and quiet. Vultures descend to continue the cleanup. The energy chain closes again. Returning nutrients to new life. In the Serengeti, true strength is not measured by violence. It is defined by order. An order formed through millions of years of evolution, where every movement and every breath serve the function of the planet itself. Multiple predator species live on the same plain. They share space, but they rarely share opportunity. Each species uses a distinct strategy to adapt to scarce energy resources. In the dim light of early morning, the vocalization of spotted hyenas carries across the savanna. That sound is not human laughter. It is a complex communication signal. Spotted hyenas live in a matriarchal society. Females are larger, stronger, and they lead the clan. A clan can include up to 80 individuals that split into smaller subgroups by area. Hyena jaws generate an average bite force of more than 1,100 psi. They can crush the thick bones of buffalo or zebra. Highly acidic stomach contents allow digestion of almost the entire carcass. Including horn and hide. More than 60% of a hyena's diet comes from active hunting. They coordinate encirclement tactics that rely on speed and endurance. Hyenas can lose a carcass to lions, but over time they remove remains and limit biological contamination. By processing the ecosystem's leftovers, hyenas recycle energy as organic matter back into the soil. On open ground, a pack of African wild dogs begins a hunt. This species has one of the most structured social systems among mammalian predators. Every individual participates in the shared task. They move in formation, and their speed can reach about 37 miles per hour while maintaining it longer than cheetahs. Wild dogs hunt with endurance and group tactics, not maximum sprint speed. One dog attacks the head, others cut off the escape route, and the rest push the prey past its limit. Their average hunting success can reach about 70%. After a kill, all members feed, including pups and injured adults. This equitable sharing maintains social order and increases the survival of the entire pack. Studies show that after a kill, the heart rate of wild dogs drops faster than in many other predators. This physiological response indicates that cooperative behavior reduces stress, which is an evolutionary advantage. Fewer than 6,000 African wild dogs remain in the wild today. Their loss would remove one of the most effective collaboration models in the animal world. At midday, ground temperatures can exceed 113 degrees Fahrenheit. On the horizon, a cheetah crouches in dry grass. The animal remains silent while heat shimmer distorts the air. The cheetah's body is specialized for speed. A flexible spine, a deep chest, a large heart, and lungs that occupy more than 15% of body volume support rapid acceleration. Its stride can reach about 23 feet, and it can accelerate from 0 to 62 miles per hour in about 3 seconds. This capacity comes with limits. The light frame cannot resist if lions or hyenas attempt to steal a kill. After a chase, body temperature rises quickly and forces a rest within a minute. Cheetahs therefore hunt in early morning or late afternoon when temperatures are lower and visibility remains adequate. Primary prey includes Thomson's gazelles and young impalas, which are lighter and can be subdued quickly. The cheetah represents an extreme evolutionary strategy that sacrifices strength to achieve maximum speed. In this strategy, precision and timing are more important than raw power. After a kill, a cheetah drags the carcass to shade and feeds quickly. A short delay allows hyenas or vultures to arrive and displace it. On the Serengeti, no resource remains in the possession of a single species for long. After the predators, the natural architects emerge. They do not only live within the ecosystem, they create the very environment that sustains others. The elephant is the largest land animal An adult can weigh up to 6 tons and travel dozens of miles each day in search of water. However, its true role extends far beyond survival behavior. Each step leaves deep footprints that form small depressions capable of holding rainwater. Over time, these depressions become water sources for dozens of other species. Elephants unintentionally reshape the terrain through their movement paths. When food becomes scarce, they break branches, uproot trees, and open passages through the woodland. Broken trunks, stripped bark, and exposed stems create open patches that allow sunlight to reach the ground and new grass to grow. These clearings attract antelope, buffalo, and numerous ground-dwelling birds. Elephants are generalist herbivores, consuming up to 300 pounds of grass, leaves, and bark daily. Seeds from dozens of plant species pass through their digestive systems and germinate in nutrient-rich dung. Each elephant functions as a mobile seed dispersal unit, expanding vegetation along its migratory routes. During prolonged droughts, memory becomes a survival tool. Older elephants lead the herd to underground water sources known from decades earlier. This collective memory passes through generations, ensuring the herd's survival. Elephants communicate using low-frequency calls that travel more than 6 miles through the ground. This allows distant herds to stay connected and share information about water and rainfall. They communicate not only through sound, but also through vibrations sensed by their feet. Elephants are the living memory of the water system, storing information about rain, soil, and vegetation within their behavior. If elephants are the engineers of the land, Cape buffalo are the defenders of the grasslands. A mature bull can weigh over 2,000 pounds, with horns dense and strong as steel. Their true power lies not in individuals, but in unity. When attacked by lions, the herd does not scatter in panic. They form a circle, placing calves in the center and adult males on the perimeter. Each step forward serves as a warning, and each horn thrust as a deterrent. Buffalo have been observed returning to confront predators. An injured lion may be attacked again, not out of revenge, but to eliminate future threats. This is a group defense strategy refined through hundreds of generations. Buffalo also shape the structure of grasslands. By grazing close to the ground, they stimulate regrowth of fresh shoots. Their dung is rich in nitrogen, replenishing nutrients in the topsoil. Moving herds act as mobile fertilizer systems, spreading organic matter across hundreds of miles. In wetlands, their footprints create shallow channels that help water flow and aquatic grasses grow. Ground birds such as storks and herons, as well as reptiles, follow herds to feed on disturbed insects. Every movement of buffalo triggers a biological chain reaction. They maintain the mechanical balance of the plains, where body weight preserves soil texture and movement redistributes energy through the Earth's surface. While elephants and buffalo work at ground level, giraffes control the upper layer of the ecosystem. With an average height of more than 16 feet, they reach leaves that no other species can access. A giraffe can consume over 66 pounds of acacia leaves in a single day. By feeding selectively on high foliage, they prevent canopy overgrowth and allow sunlight to reach the ground. That sunlight fuels grass growth, which supports herbivores below. Giraffes have a unique circulatory system. Their hearts weigh about 24 pounds and generate enough pressure to pump blood more than 8 feet upward to the brain. One-way valves in the neck arteries prevent vessel rupture when lowering the head to drink. This design demonstrates evolutionary adaptation to gravitational stress. Giraffes move gracefully through sparse woodlands, serving as natural trimmers of tree canopies. Their browsing behavior prevents acacia and mopane trees from dominating, maintaining diversity in the upper vegetation layer. Without giraffes, ecosystems would shift toward single-species tree dominance. Their saliva contains antibacterial compounds that help tree wounds heal quickly, reducing fungal growth. This small detail demonstrates a subtle but essential symbiosis between animal and plant life. Giraffes sleep only for brief periods while standing, always alert. They remain prime targets for lions. But a single defensive kick can seriously injure or kill a predator. Nature allows no weakness to persist, and giraffes embody passive defense, rarely fighting but difficult to defeat. Three species, operating at 3 levels, shape the Serengeti ecosystem. Elephants sculpt the soil and create water sources. Buffalo maintain grasslands and nutrient cycles. Giraffes regulate the tree canopy. Together, they do more than use resources, they enable their regeneration. When one of these large species declines, the recovery chain breaks. Soil becomes compacted, water fails to infiltrate, grasslands thin out, and natural fires intensify. A decline in elephants leads to denser tree growth, reduced sunlight at ground level, less grass, fewer antelope, and eventually fewer lions. A decline in buffalo reduces soil nutrients, allowing shrubs to expand and closing open grasslands. The disappearance of giraffes results in thick canopies dominated by acacia, reducing plant diversity. The savanna's ecological balance depends not on a single species, but on interactions across size, levels from insects to animals weighing several tons. The African landscape is the product of millions of years of interaction among fire, water, and these giants. Their behaviors form a self-regulating feedback system. There is no central control, no plan, Yet the result is long-term stability. As the dry season ends, elephants move southwest, following the flow of water toward the Okavango. Buffalo follow behind, leaving deep prints in the mud. Overhead, giraffes move through belts of acacia, feeding on the last tender leaves before they fall. Each movement represents not only migration, but also the transfer of regenerative energy from soil to plant to animal and back to soil. With the next rainy season, the areas they crossed become richer. Grass grows thicker, seeds germinate faster, and water sources stabilize. The landscape renews itself through the behavior of the species that inhabit it. Across Africa's biological map, elephant tracks, buffalo trails, and the silhouettes of giraffe canopies are not just signs of life. They are the geometric language of the planet, a record of how Earth adjusts itself to sustain its own rhythm of life. From the dry plains of the Serengeti to the humid rainforests of the Amazon, the planet operates as a single living system. Water begins as rain, moves through soil, vegetation, and organisms. Solar energy passes through leaves, through flesh, and returns to the atmosphere. No flow is ever lost. It only changes form. Lions maintain order within the grasslands. Hippos carve channels that keep the rivers moving. Leafcutter ants sustain cycles of renewal beneath the trees. From the largest creatures to the smallest, every movement is part of the same biological mechanism. On a global scale, winds carry dust from the Sahara to the Amazon. Rain from the Andes flows into the Orinoco Basin. Water vapor rises, forms clouds, and falls again where it began. This is the planet's circulatory rhythm, slow, steady, and continuous. Each ecosystem functions as a heartbeat within Earth's greater pulse. When one heartbeat falters, the entire system responds. Life is not a miracle. It is the result of equilibrium between energy, water, and time. In the sky, vapor condenses into rain. In the soil, seeds begin to sprout. Everything starts again, as it has for millions of years. Viewed from afar, this small blue planet is more than a place where we live. It is the only unified system known to create life and to sustain it.